Let's solve this integral, the integral of x squared minus x plus 4 over x cubed plus 4x dx. We're going to use the method of partial fractions, so first we have to fully factor the denominator. This factors into a linear factor and an irreducible quadratic. Now we can set up the partial fraction decomposition. The first factor would just be x, that's linear. Let's stick a coefficient on top of that. The second fraction is an irreducible quadratic, so that needs a linear coefficient, so we can use bx plus c. Now we're going to multiply through by the denominator of the left-hand side to cancel out all the fractions. So I've written this out, multiplying through, and now we can cancel the x's on that term and cancel the x squareds plus 4's. This leaves us with ax squared plus 4a plus bx squared plus cx, and all of that is equal to x squared minus x plus 4. The next step is to go ahead and combine like terms, so we can find all of our x squareds, and on the left-hand side the coefficient is a 1. On the right-hand side we're going to have an a and a b, so we get the equation 1 equals a plus b. The linear term for x, we have a negative 1 on the left-hand side, and on the right-hand side we have a c. For the constant, on the left-hand side we have a 4, and on the right-hand side we have 4a. So now we can solve these equations. We already get that c is equal to negative 1. Here we get that a is equal to 1, and then we can use the top equation to solve for b, and we get that b is equal to 0. Now we can come back to our partial fraction decomposition and filling in the coefficients. So a is 1, we get 1 over x. B is 0, so we'd have 0x plus c. C is a negative 1, so we get negative 1 over x squared plus 4. We can rewrite this as 1 over x minus 1 over x squared plus 4. Then we can take this back to the original integral, and we have the integral of 1 over x minus 1 over x squared plus 4 dx. And solving this, we get the natural log of the absolute value of x. The second term is arctangent, with the value here being 2. And so we will get a negative 1 over 2 arctan of x over 2, tacking on the constant of integration, and we are done.